Hello, and today we're going to look at the universal soil loss equation. And that's this rather intimidating looking equation that you can see that we'll go through bit by bit and figure out how to use it, okay? And the purpose of this is it allows or us to estimate soil loss rates. And then this allows us also to assess impact of changes to agricultural practices. So we can see if it's worth doing or investing in to help protect our fertile, arable or farming soils. So if we have a look at this formula, is all the maths for it is quite simple. It's all multiplications. And it is A equals R multiplied by K multiplied by L multiplied by S multiplied by C multiplied by P. Okay, so what do all these letters mean? The first one is A, which is what we're trying to calculate, and that is rate of soil erosion. So how quickly local conditions and practices affect erosion, and this is calculated, or the units, sorry, are in tons per hectare per year. So that's the unit that we need to be aware of that we are using. So it's always important to remember the units. Okay, all the others are factors, which means that they don't necessarily have units to go with them. All right, so the first one is rainfall erosivity factor, R. And this is the measure of how effectively rainfall can erode soils. So this is dependent on the time that we have rain falling. So how long on average per year is it raining? The intensity, the frequency of rain. So how heavy it is it just a gentle mizzle, or is it a heavy like downpour? Is it all the time? Is it only occasionally? And we can get this value from sort of central held databases like this, which give us our R factor. And we can look up our location and see that some areas have really high rainfall erosivity factors, so like the west coast of Scotland and Wales and sort of Dartmoor and Exmoor and stuff like that. And other areas are much lower, so things like the southeast and the east coast of Scotland, places like that, they just don't get quite the same amount of rain or intensity of rain. The next one is the soil erodibility factor, which is our K. And this is this is like the soil texture, typically, is what affects this. So how easy is it for soil particles to be eroded? And again, we look this up in a table. So different types of soil. So here we've got things like sand has a K factor of 0.04. Okay, and you can see the units there, tons per hectare. Whereas something like silty clay loam has a much higher erosivity factor, so 0.72, so that's tons per hectare. So different sort of textures of soil will have different, will be affected by the process of erosion in different ways. Next one then is slope length. So this is a question of how long is the slope. So the longer a slope is, there's going to be a greater amount of kinetic energy in the water running along the surface, so that'll have a higher erosivity factor. And slope gradient is how steep is the slope. So steep slopes, again, are going to have more kinetic energy. All right, and if we look at a table that gives us this, we have our slope length in the first column, our slope gradient, which is a percentage, and that gives us our factor. All right, so if we have a really long slope with a really steep angle or gradient, we have a really high L factor. If we have a short slope with a very low gradient, we have a very low L factor. And these, you can see, we sort of multiplied these two together to give us that total factor. Okay, so they sort of they can be written as LS sometimes. And the last one, last two then, we've got crop management factor. So this is a combination of what we are growing and when we are sowing it, so our tillage. So are we doing it in the autumn or in the winter, or is it zero tillage or something like that? Okay. And you can see we have a lookup tables to do this as well. So to work out that factor, we need to multiply together our two lookups together. So for C, our C factor, we have two tables that we need to check against. So say we have something like grain, we can see that we have a factor of 0.4. And if we are doing autumn ploughing for it, we have a factor of 1. So to work out that, it's 0.4 multiplied by 1.0, and that will give us 0.4. Okay, and that gives us our C factor. All right, and you can do that for any combination of those. So there's that one. And then the last one is our erosion control factor. So this is what specific methods are we using to try and control the impact of things like ploughing. So are we, it can be written as like a support practice. So type of ploughing. And we can look that up again in a table. So down here we have our support practices. So we got things like up and down slope ploughing, cross slope ploughing, contour ploughing, strip cropping, cross slope ploughing, strip cropping, and contour ploughing. So there's a variety of factors that can be multiplied. And you can see our worst case up and down slope ploughing has the highest factor, and our best case strip cropping with contour ploughing has our lowest factor. And then you multiply those all together, and that gives you your rate of soil erosion in tons per hectare per year.